Good morning, dear children. Today we'll start with a new part of the same chapter, okay, energy, some technical terms related with simple machines. In the last class, I explained you about what is simple machine, lever, the different types of lever, the three classes of lever, okay. All these things I have explained you. Now today, let us come to the few terms which are related with simple machines. Now, what are the terms which are related with simple machine? When you talk about simple machine, you should remember all these things. So, number one is the fulcrum, second one is the load, third one is the effort, fourth one is the velocity ratio, fifth one is mechanical advantage, sixth one is work input, seventh one work output, eighth one is the efficiency. Okay, so these are the terms which you should remember when you study simple machines. Now let us come to the first term, fulcrum, and this fulcrum is symbolically, it is written as capital letter F. So that capital letter F in a simple machine denotes a fulcrum. Now this fulcrum, it is a point, it is a fixed point in which a machine turns. It is a fixed point on a simple machine in which a machine turns. Okay. Now example I'll give you. You take a pair of scissors. Okay. A scissor has got two blades. Okay. And the two blades are fixed at one point, and you have seen in the scissor, you have seen at the near the blade of a scissor, on a blade of a scissor, there is a point. There is a screw, some sort of screw is there. Okay. Now if you remove the screw, okay, if you untie the screw or if you remove the screw from the scissor, what will happen? The two blades gets separated. They will become apart. So that means you cannot cut you cannot cut a cloth or a paper, okay, or the simple or that pair of scissors will not be able to perform any work. So that means in order to make that scissor to work, that a blade of scissor are fixed at one point, that is known as the fulcrum. And within that fulcrum, okay, because of that fulcrum, the blade of that scissor will turn or it will move. Okay, so that point we call it as a fulcrum. So even in a seesaw, you can see, you know the seesaw, okay. So now the seesaw is supported. So what happens on the two sides? The load is placed here. That means two of you, one person can sit on the one edge of a seesaw and another person can also sit there. Okay, so what happens there? If one person alone will sit there, what will happen? The person who is sitting on one side or the one edge of a seesaw, it comes down and other edge it comes up. Okay, so again another person if he sits on the other edge, again the other side it moves up. So that means seesaw, it moves up and down depending upon the load which has been placed at the edge of the seesaw. Now this seesaw, it does not move from one place to another. Okay, it is fixed at one point and it is fixed at the center. Center there is some point or some screw or some sort of rigid fixed support is there at the center. And within that point, what will happen? The seesaw will move only up and down. So that point we call it as a fulcrum. Okay. So even in a crowbar, okay, crowbar means a long rod which are used to turn a heavy load, that is a stone or lift a stone. Okay. So in a crowbar also, okay, so suppose you want to turn a stone, a huge stone is there, and it becomes impossible to turn that stone with your hand. Okay, it becomes very difficult. So you use a simple machine there. So when you use a simple machine, while turning that stone, okay, at one point you will keep some object there. Okay, suppose the stone is here and you want to turn the stone, and near the stone, okay, and stone is considered as a load, okay, and near the stone you will keep one object. And that object will consider as a support to turn the stone. So that one we call it as a fulcrum. Okay, so always in a machine there is a presence of fulcrum, and fulcrum is a fixed point about which the machine turns. So that is number 1. Next one is a load. So load can be written as L. Okay, capital letter L denotes the load. Load means the force exerted by the machine. Okay, load means the force exerted by the machine is called the load. Okay, example I will give you another one. Other is also here. That means the force before this, the force applied to the machine to move a load. The force applied to the machine to move a load, that is known as the effort. And effort is given by your side, from your body, that means from you. Okay, now I will give you one example of this load and effort. Okay, suppose the scissor, let us take the same example, scissor. You want to cut with the help of scissor, you will cut a paper or a cloth in a different shape or a different size. You can use blade also, other knife also you can use it, no matter. Okay, you can cut it, but you cannot cut in a perfectly. You cannot cut that paper or a cloth perfectly. That means it doesn't form a particular shape or a size you want to cut. So you use a scissor. So scissor is very easy. Okay, in order to cut a paper or a cloth or anything, you can cut it with the help of scissor. Now let us consider a scissor here. Now this scissor, unless and until if you don't apply the force on that scissor, the scissor itself does not work. Listen very carefully. Okay. Suppose I bring a scissor, I want to cut a paper or a cloth, and I just keep that scissor on the table, and I just fold my hand and I just observe it, the paper as well as the scissor. The scissor themselves will not cut the paper. First of all, what we have to do, we have to hold the scissor on your hand. Then we have to move, okay, the blade of the scissor. Then only the paper or cloth will be cut by a scissor. Which means that when you apply a force on that scissor, that scissor is a machine. Okay, when we apply the force on the scissor, now that force we call it as the effort. Okay, and the paper or a cloth, by applying a force on the scissor, now that paper or a cloth you can cut it. And how the paper or a cloth can be cut? When you apply the effort on the scissor, the blade of the scissor will start moving. And when it start moving, okay, the paper or a cloth will be cut. Okay, so that means that paper or a cloth is considered as a load. That is considered as a load. So from here, load and the effort. Okay, now the load. Again I tell you that load. What is the load? The force exerted. Okay, by the machine. The force exerted by the machine to do a work. The force exerted by the machine to do the work is called the load. Okay, first you apply the effort on the machine, and when you apply the effort on the machine will exert a force, okay, to the load. Load means a paper or a scissor. Then that machine will do the work. So therefore, load is the force exerted by the machine to do a work. Similarly, effort. Effort is the force exerted to the machine. See the difference. Load, the force exerted by the machine to do the work. Effort, the force exerted on the machine. First of all, you apply the force on the machine. Okay, so that is the effort. Understood? So these are the two terms, load and the effort. So how they can be differentiated? Okay, so how we can understand about which one is the load, which one is the effort. So that means effort you will apply it from yourself. Okay, you will apply the force on the machine. So that force which is applied on the machine, that is the force exerted on the machine, we call it as the effort. And the force exerted by the machine is known as the load. Okay, so next one is here. So regarding with this load and effort, okay, I'll explain you about the effort and load arm also. Suppose I'll take a long lever. This is the lever. Okay, this is the lever. Let us consider at the center there is a fulcrum. Fulcrum means a fixed point. Okay, one side, this side I'll apply a load here. This side is the load, okay, and this side is the effort, and here is the fulcrum. So the another point is there regarding with this load and effort. Okay, the distance from the fulcrum to the load is known as the load arm. Remember this one also. Load arm. The distance from the fulcrum to the load, to this distance, fulcrum to the load, that distance is known as the load arm. Similarly, the distance from the fulcrum to the effort, other side is the effort. Okay, so that is known as the effort arm. Remember that. So another point is here regarding which is related to this load and effort arm and the load arm. So again I tell you that load arm means the distance from the fulcrum to the load is known as the load arm, and the distance from the fulcrum to the effort is known as the effort arm. Okay. Next one comes the velocity ratio, which can be written as VR. Now this velocity ratio is defined as the ratio of the velocity. It is the ratio. Okay, mathematics also you have done. Okay, ratio. It is the ratio of the velocity of the effort to the velocity of load. Which means, what does it mean is that means it is the velocity that traveled, or the distance traveled by the effort to the distance traveled by the load. I'll give you one example. Let us consider a pulley. Okay, pulley. So pulley, it is a circular wheel. Okay, and around the wheel there is a groove ring. Okay, there is a ring, or the groove ring we call it. So around that ring, okay, around that now this is the pulley, and around this is known as the groove ring, and in this ring there is the rope or a string will wind around it. It is wind around it. On one side we apply the effort, and other side is the load. Okay, this is the load here. This is load, and this side is effort. I am giving the example of pulley. Okay. Now this pulley, this side is the load, other side is the effort. Okay. Now this load, let us consider a bucket. Okay. Now this pulley can be used to draw the water from the well. Okay. Two types of pulleys are there. Already I have told you, single fixed pulley and single movable pulley. So I am discussing only about the pulley. Okay. Now consider this as a bucket. Now you want to draw the water from the well. Now you just what will do is that now you just leave that rope here, okay, or a string. You just leave the string here. When you leave the string, what will happen? This wheel will rotate. It will move around it, and it will not move from one place to another, since it is fixed at one point and it is fixed by a fulcrum here. And this rope or a string, it keeps on moving, and therefore what will happen? The string will move down here. It moves down. And you fill the bucket with water. Once you fill the bucket with water, what you do? Now you pull the string in the downward direction like this. So when you pull the string in the downward direction, what will happen? That string will cover a distance. Okay, so that we call it as a velocity of effort, because here we are applying the effort, we are applying the force. Okay, now when you pull the string here, okay, when you pull the string, this load will move up. So that means when you pull the string here on this side, on the right hand side, left hand side there is a load. Once you pull the string gets stretched. Okay, and when you keep on pulling the string, the load will keep on moving up. So therefore what happens here is that now when you pull the string here in a downward direction, what will happen? The distance is covered by the effort. At the same time, here the distance is traveled by the load. So that we call it as a velocity ratio. So the velocity ratio is defined as the velocity of the effort divided by the velocity of the load. Is it clear? So this is the velocity ratio. That means the distance traveled over the distance moved by the effort to the distance moved by the load. Next one comes the mechanical advantage. Mechanical advantage is also the ratio. Okay. It is the ratio of load to the effort. It is the ratio of load to the effort. Okay, so load means the force. It is the ratio of the force exerted by the machine to the force exerted on the machine. Okay, load, force exerted by the machine. Effort, force exerted on the machine. First we have to apply the force on the machine. Okay, so in other way also you can define here. Mechanical advantage is the ratio of load to the effort, or load means it is the force exerted by the machine to the force exerted by the machine. Okay, so and it can also be written as mechanical advantage can also be defined as EA divided by LA. EA means effort arm divided by load arm. Okay, so if the effort arm and load arm is given, you can find mechanical advantage by using this relation effort arm divided by load arm. So therefore, mechanical advantage and velocity ratio both are the ratio of the velocity of effort and velocity of load. Similarly, velocity of load to the velocity of effort, so they don't have any unit. Unit means you know that, okay? Unit of mass is kilogram, unit of velocity is meter per second, okay? Unit of distance is meter, centimeter. So all these units they don't have. Since they are the ratio of two quantity here, okay? Load and the effort and the velocity of load to the effort, so they don't have unit. Okay. Next one comes the work input. Okay, work input. So work input means the work done on the machine. Work input means work done on the machine. We call it as a work input. Work output means work done by the machine. Okay, work input, work done on the machine. That is the input. That means how the work is done on the machine. When you apply the force on the machine, then only the work will be done by the machine. By itself, machine themselves will not be able to perform any work. Remember that. Okay, I give you the example of a scissor. I give you the example of another example. I can give you as a car jack. You know that car jack. Okay, suppose you are traveling in a vehicle. On the way, suddenly the tire gets punctured. You have to replace the tire. Okay, and you have to fix the new one, the new tire, the proper tire. So what you do? You cannot lift the vehicle by yourself, okay, and you can change the tire. So you use a very simple machine, that is car jack. Car jack is very small, but they do a very large amount of work. And the effort applied is very less. You apply very less force, but a large amount of work is done. Okay, so you take if you want to change the tire of a vehicle, okay, you just put a car jack under the vehicle, near the wheel of the vehicle, okay, and you apply the force on that car jack. Okay, when you apply the force on the car jack, and the car jack will now do the work, and that car jack will now lift the vehicle. So car jack themselves will not be able to do the work. So same like that, work input means the work done on the machine. Work input is work done on the machine. Okay, first of all you have to do some work on the machine. Then only the work is done by the machine. And the work output means work done by the machine. Okay, so this is work input and work output. Next one is the efficiency. Efficiency means it is the ratio. It is also the ratio. It is also the ratio of the work output divided by the work input. Okay, and work output is always greater than the work input. Work input means you are applying the force to the machine, and you have to apply very little force to the machine. Less energy you will apply to the machine, but the machine will do a large amount of work. So therefore, efficiency can be written as work output divided by work input into 100. So that means efficiency is always calculated in percentage. It is always calculated in percentage. 80%, 40%, 50%. Okay. Efficiency means capability, ability to do some work. Okay. The meaning of efficiency means capability, ability. So every machine has got efficiency. And efficiency, how you calculate? Efficiency equals to work output divided by work input. Okay, and work output is always greater than the work input. Work output means the work done by the machine. Work input means the work done on the machine. Okay, so into 100. So these are the terms which are associated with simple machines.